So let's talk a little bit more about arithmetic operators, which we've already been using quite a bit. So I'll just move this stuff down here because we already talked about this. So let's just start with the blank version of this function and try something like, let's switch from integer to a double value, and I'll call it d value for the lack of better name. And we'll try something like 7.0 divided by 3.0. Notice I'm starting to use decimal point, which is a common practice when we use real numbers, which is the double floating point data type expects us to use. Let's display this. Stream and just say display what this is. So we'll just use this expression to say this equals. I'll use double equal sign to show the equality here and display what the value becomes. And also a new line, character at the end, something like this. So pretty simple. We can build this. It does build fine. Pressing Ctrl F5 to run the program. And this is what it shows, right? So this is quite expected. You can do it with the pencil and paper, and you should pretty much get similar result if you try it. Okay. Next thing I'd like to try is to do exactly the same thing with an integer. I'll call it I value because it's my integer value. Equals 7. Of course, there's no more fractional part because it's an integer. There's no fractions. Divided by 3. Okay. And copy and paste something very, very similar to this. We just try to use get rid of fractional parts and display the I value, the result. So this builds fine. So hopefully we'll see two messages right here. And look what happens if we switch from the double to an int. The fractional parts are gone, fractional rules of division are gone, and you see that basically what we end up with is that 7 divided by 3 in the most basic perspective is that the result is 2, and of course the remainder is 1, because 6 divided by 3 is 2, and the difference between 6 and 7 is 1, right? So there's a remainder, and when we use this division, in this situation, the remainder is thrown out. It's not used. It's discarded completely, right? So this is the rules. What this means is that you may expect almost, in fact, this is the two absolutely different approaches to do the division. It's two approaches here to do the division with doubles. You know what it is. It's going to equal something like this. And when you use the integers, when you're doing your division, you see that the integer division, the rule is to give you the result, and the remainder is thrown away. In addition to all of this, there is also another part of the division, which is a division by 0. So what happens if we attempt to divide by 0? So instead of dividing by 3, we change this to a 0. You know from the arithmetic classes that division by 0 in math is undefined. Essentially, it's something unknown to the mathematics. So in computer science, in your hardware, division by 0 is also undefined, and therefore it behaves different compared to any other kind of division. Right, so we change this. Let's just make this one change. Save it and try building it. Okay, so the compiler really says that because I know that division by 0 is not a good thing, I'm not even trying to compile this code. Somehow you need to make a change. So this, maybe it's the wrong operation or maybe it's the wrong value, but in either case you need to make a change. Do something about this. I'm not going to compile this. So let's trick the compiler and introduce some sort of divisor. Right? So we just introduce some kind of divisor value right here. So let's make it a double and just divisor. Okay, divisor, declare it and get it from standard input. Just read this value like this, and of course if we do it, then we need to probably tell the user what we're asking. Okay, so we do something like this. So this way I'm getting in the way of the compiler figuring it out so easily. I'm going to enter 0 and then use this as a variable. Right, so I'm saving it and let's build. Okay, let's build. And there's a missing semicolon right here. That's okay. And I press Ctrl F5 to run it. So of course I'm going to enter 0. And you see that the double data type has a special encoding that's possible in a double value, which indicates an infinity. When the specially encoded result is sent to cout right here, when we print 7, oh, this is also hard-coded, so we need to change this as well. Let's fix it. So we better replace this by saying whatever the divisor is. I just insert the divisor here. Run it again. So again, I'm just going to say 0, and I don't care about the integer part yet. I'm just trying to see what this is. So it says here 7 divided by 0 equals infinity. And just be aware that this is a special value and this is the behavior to expect from the double data type. If you happen to or end up dividing something by 0 and the way your program is compiled is to use double floating point division, it's just going to give you this type of thing, which is probably not a good thing, because from that point on, if you try to use it further, everything will become just not a number. So before continue with any of this, let's also compare this with an integer. Okay, so let's just change this divisor to an integer. It doesn't matter, because when we use the division, and if this is an integer and this is a double, our integer will be promoted to a double. And so this time I will also use, actually let's just check that everything behaves exactly the same way. Okay, so build quickly and run it. 0, it's the same result. So now let's also use the divisor, which is now is an integer. I declared this an integer, I'm getting it as an integer, and now I'm dividing 7 by this divisor. So 0, and let's wait. I mean, on my system right here, this executable has finished with some strange result, which apparently indicates the exception that this has thrown as a result of dividing by 0 using the integer division. So in case of an integer, you see that the behavior is different. The process crashes, the program misbehaves, your CPU detects attempt to divide by 0, notifies the operating system terminates the process and returns for us this error number, which indicates, by the way, integer division by 0. If you get something strange like this, and of course I was just running without debugging, now let's just close this window, and this time we can say debug and start debugging. So in debug mode, now we can perhaps expect a little bit more information from this session. So 0, okay, and here it is, unhandled exception in our code, in our program, and this is the code of the exception, and this is integer division by 0. Okay, and this code, I suspect, is actually the, let's just maybe try the calculator. Okay, try the calculator, and I have already switched to programming mode, but you need to switch to programmer mode if you hadn't already. Do a hex value, and this seems to be 32-bit value, so I'll change to a double word, which is 32-bit value, and then just copy from here and paste it here. Okay, so you see that this is yeah, it gives us the negative number, but you get the idea. In debug mode, you get much easier explanation of what happened during the runtime. So be it. This is just a quick look at this, and I don't want to talk about this for a very long time. Okay, so I'll now simply say debug, stop debugging. Okay, and so this time from debugging session it exited with -1. So you see that this is something specific to the program loader or operating environment. I simply don't know the exact answer where this is generated, but anything non-zero indicates something really bad. Okay. I would like to tell you that there is no defense against division by 0 with integer type of division, rather than preventing this division from happening by using some sort of an if statement. In other words, if I want to defend from this terrible crash, instead of doing it like this, what I would have to do is just declare the variable and say something like if this divisor, if divisor does not equal 0, then let's do it. We're just gonna say I value equals whatever's been happening, and we just do it this way. So this is the only way to protect yourself from crash as a result of division by 0 using an integer division. Unlike integer division, when we use double format for this division, there was no bad outcome, rather than the value became an infinity value, and rather than that, it was not crashing the program. It just silently let it go. This is a big danger sign for you as a programmer. I would actually be happier if, in many cases, if this was behaving just like an integer, simply crash the program. But unfortunately, in math, it's very possible to, like, especially in vector math, when you're using large arrays of data, dividing them by other large array of data, and when it goes optimized and vector math capable hardware, it's just inevitable to to sometimes run into this and expect these types of results, like this infinity result as a result of floating point division. So that's a topic for another day. But anyway, the behavior is different. And in here, by the way, there are the line of defense over here is that you can detect it like this. If is infinity, this thing right here, d-value. Okay, we'll just try to use a function to determine this. We can then say I'll use error output just to demonstrate that this is something incorrect happening in the program, and we'll say division by 0 detected. So we just want to be able to detect this, and I'll use new line right here. Okay, so let's see if this works, and we'll just exit return 1 from right here. From this point on, we'll just indicate, okay, this really didn't go too well, we just have to stop. So let's see if this works, except that I need to include another header, and it's a CMath header right here. So let's build, just see if everything works. Yes, it does. So let's see if we can if we will see this message or not, and if this function will allow us to check the value, the result of this division, and detect it. So pressing Ctrl F5, again dividing by 0, our very special case. And here we're just exiting out of this, and this time it's much more predictable because this is us returning 1, and we exited with code 1. Apparently this all makes sense right now. So just be aware of these situations, and we will be covering floating point arithmetics and floating point division, of course, a little bit more in our future courses. But for now, just a highlight of how different the behavior is compared between the doubles and integers.